have you ever wondered, when you shine a light through the bars in the pits, can it actually do a difference?
And can we simple meters actually change the path the appearance of light is surprisingly weeks?
And why does light travel differently to clear liquids than those light movements?
Additionally, how do you see the ingredients in salt, sand, or milk affect the way light moves through water? I'm Alexander Gabino.
I am Alicia Alarilla.
I'm John Vincent Manalon.
And I am Rosel Bantico. So for our today's agenda, we're going to conduct a simple experiment called
Mixing it up.
that depicts how light will pass through different kinds of fluids. So without further ado, let's dive into our experiment.
So, based on our observation, when the salt was put in the water, some of the particles of the salt got easily dissolved, some of it goes down at the bottom. And when it is stirred, the salt got divisible and became like a water. Since the salt got dissolved, the light just easily passed through.
Now, let's do the same step with beaker B. Put the water in the beaker, mix the sand with water, and stir and observe.
When the sand was put at the beaker with the 100 milliliters of water, the sand goes down at the bottom of the beaker. And when it started to stir, the sand does not mix well with the water because it has a solid particle. It has the same with the salt. Even it has a small particles at the bottom.
Let's do the same steps with beaker C, our last beaker that contained milk and water.
Have you noticed any changes after mixing the milk and water? The resultant mixture of water and milk possesses an opaque, milky appearance. Since the water dilutes the pure white color of the milk, the mixture's color will be lighter than the pure milk itself. Did the mixture also pass the flashlight test? No. Rather, when a flashlight is illuminated through milk, the light does not travel in a straight path. Instead, it scatters due to the proteins and microscopic fat droplets suspended in it. Another term for this phenomenon is called the Tyndall effect.
Let's recall my companion's earlier observation about beaker A, which contains salt and water. As Miss Alexandra mentioned, the salt particles dissolved, forming a homogeneous mixture that appeared uniform with no visible changes. Did you listen and watch carefully to what Miss Alexandra observed about the beaker B? If so, let's recall them. The sand particles did not dissolve in the water. Instead, they sank to the bottom. Since it did not dissolve, it is a heterogeneous mixture with two phases. The liquid as water and the solid, which is the sand.
The milk directly passes through water and it has the same proportion of its components. And when it started to stir, the milk and water was uniformly mixed, and this is an example of homogeneous mixture with one phase.
Among the mixtures of rock salt, sand, and milk, rock salt and sand are the mixtures that allow the light of the flashlight to go through a straight path. In contrast, the mixture of milk causes light to be scattered due to their colloidal particles.